Okay, this is 4.1 talking about parallelograms. So we're getting into the unit on quadrilaterals. Okay, so a quadrilateral, like we know, is a polygon that has 4 sides. So we have this here, A, B, C, D. Now we write it in the order of the letters. So it's A, B, C, D, how we connect them. You're not going to write A, C, B, D, because that's not how we have this labeled. Now let's say if I have P as the set of polygons and Q as the set of quadrilaterals, that brings up a good topic about what this stands for. It's a weird little symbol and it has a C with a line under it. This means subset of. So if I talk about polygons being a subset of quadrilaterals, is that true or false? Well, quadrilaterals are a type of polygon, so that's false. But if we write quadrilaterals is a subset of polygons, yeah, that's true. Quadrilaterals are a type of polygon. When we talk about parallelograms, okay, parallelograms are quadrilaterals in which both pairs of opposite sides are parallel. So this side here is parallel to this one, and this one here is parallel to this one. So we usually use this little symbol in front, or we just write the word parallelogram in front of however we label it. So again, you would label this RSTV, okay, or RSTV or RSTV. It doesn't matter, as long as we label them in order. Now, what do we think we know about the angles here of a parallelogram? What do I know about these 2 angles and these 2 angles? All right, we know that opposite angles here are congruent. Why do we know that? Well, if I have 2 parallel lines cut by a transversal, I know that this angle and this angle have to add up to 180, right? Because they're supplementary. If I have that this is parallel to this, then this is the transversal. These 2 have to add up to 180, so therefore these have to be the same by the transitive property. So think about all of your rules about parallel lines and what you know about the angles that are formed from 2 parallel lines being crossed by a transversal. So in this way, you might have to look at it with these on top first and then these on top second. So you might have to turn your paper 90 degrees. All right, the diagonal of a parallelogram separates the parallelogram into 2 congruent triangles. Now, why do we think that's true? So here's my parallelogram, and I have a diagonal right here. Why do we think that this has to be 2 congruent triangles? Well, we know that this angle is congruent to this angle, and we know that this is congruent to itself. What else do we know? Well, we know that for a parallelogram, all the sides are parallel, so they have to be exactly the same distance apart the whole way. So that means that these are congruent and these are congruent. So we could say by side angle side or side 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 that these 2 are congruent. So this is going to be important. Okay, now let's talk about some important properties of parallelograms. So for the first one, we have that opposite angles are congruent. Okay, so that's one of them. We also have that opposite sides are congruent. That's what I was talking about before. The diagonals bisect each other. Okay, and consecutive angles are supplementary. Maybe. Okay, so in this way, if we look at the diagonals bisecting each other, I have here is my parallelogram, and I have the diagonal cross and this diagonal here. So this tells me that these are congruent and these are congruent. That does not necessarily mean that this one here is congruent to this one here, but we know that this part of the diagonal is congruent to this one, and this one is congruent to that one. Why do we know that consecutive angles are supplementary? So if I draw my parallelogram again, consecutive angles are angles that are right next to each other. So this one and this one, or this one and this one. Now I already talked about this earlier, but why are consecutive angles supplementary? What does supplementary mean? Well, it means they add up to 180. We know that these are parallel, and because of our rules of parallel lines, we know that this and this have to add up to 180. So two angles that are right next to each other are supplementary. Okay, altitude of a parallelogram. The altitude of a parallelogram is a line segment from one vertex, so from up here, that is perpendicular to a non-adjacent side. So these would be the adjacent sides, so it would be perpendicular to this one here. So if I go ahead and draw that in, here's my vertex, and I drop it straight down, and it's perpendicular. Okay? It may or may not be inside the triangle, or inside the parallelogram, excuse me. So from here, if this is my vertex, I can drop it straight down here, so it makes a right angle. Or I can extend this side out and I can drop it straight down from this vertex where it forms a right angle. So if I were to extend that side, okay, so it might be inside the parallelogram or it might lie outside the parallelogram. An altitude of a parallelogram is going to be exactly the same basically as a triangle, except we're just going to the side that's across from it. So altitudes are perpendicular to the side that's across from the vertex. Now, lengths of diagonals. So what do we know about lengths of diagonals? For example, I'm given this parallelogram here with this angle and this angle. Now we can tell from the picture that this one's probably bigger, so let's just go ahead and say that this angle is bigger than this angle. So we're going to go ahead, if I label this, it says A, B, C, D. Go ahead and label these as well. Okay, so let's say that angle A is obtuse and angle D is acute. So what does that tell me about segments BD and AC? So I know that this angle is obtuse and this angle is acute. So what does that tell me about this segment versus this segment? You can even tell from the picture. BD is much greater than AC. Remember, if you have unequal angles in a parallelogram, okay, the longer diagonal, so the longer diagonal is opposite the largest angle, okay, and the obtuse angle. And that's because of what we know about triangles, right? We know that the largest side in the triangle is across from the largest angle.